Alright guys, now here, for question 3, we've got the position vectors of points A and B relative to an origin O are given by the following. Okay, K is a constant. So find the value of K for which the angle AOB is 90 degrees. Well, how do we do that? How do we approach this question? Well, the way we'd approach this question is to say, okay, well, first off, if AOB is equal to 90 degrees, we can comfortably say that OA dot producted with OB, okay, it's going to give me 0. Okay, because remember, if the dot product equals 0, it's perpendicular. So, what does that mean? Well, that means what we can say is 6 negative 2, 6 times 3k negative 3 is going to equal 0. Which means what? Which means that 18 minus 2k minus 18 is equal to 0. 6 negative 2. Minus 6. Okay, so plus 18. So therefore 2k is going to equal 36, which means that k is going to equal 18. Easy enough. Now, next question says, find the values of k for which the lengths of OA and OB are equal. So remember, how do we find the lengths? Well, we have to find the magnitudes, right? And in order to find the magnitudes, we're going to have to find, we have to basically square these, add them and square them. So it's for II now. We'll say, okay, cool. OA let OA OB. Okay, so therefore what can we say? We can say that 6 squared plus negative 2 squared plus minus 6 squared is equal to 3 squared plus k squared plus minus 3 squared. Right? Which means what? So effectively, what does that mean? It means we're going to get root 76 is going to equal, if we add these up, 9, okay, so 18 plus k squared. Okay, so if we square both sides now, we're going to get 76 is equal to 18 plus k squared, which means that k squared is going to equal 58. So k is going to equal plus minus 58. Okay, which means that k is effectively equal to plus minus 7.62. Okay, cool. Now, for number III, the point C is such that AC is equal to 2CB. Okay, AC is equal to 2CB. So, what does that tell you? It means we have to find the values of not only AC but actually CB as well. And from there, we can create an equation to actually solve this. So, in the case where k equals 4, okay, find the unit vector is cool. It's III. Right, so AC is equal to 2CB, right? So what is AC? Well, AC is OC minus OA, okay? And what's CB? OB minus OC, okay? Cool. So OC minus OA is equal to 2 times OB minus 2OC, okay? So from there on we can say 3OC is equal to 2OB plus OA. Okay, cool. Now ask yourselves, do we have OB and OA? We do. OB and OA. So I can say that 3 OC is equal to 2 times OB. So 3k negative 3. Okay. Plus OA. 6 negative 2 negative 6. Okay, and K here is what? K here in this example is 4. Okay, so we got a 3OC. 2, 3, 4 minus 3. Plus 6 minus 2 negative 6. Okay, so 3OC. 6, 8 negative 6. Plus 6 negative 2 negative 6. Okay, so 3OC. Then it's going to equal 12. 6 minus 12. Right? Which means the OC is going to equal 4 to negative 4. Brilliant. However, we're not done yet, because remember, what it wants is the unit vector of OC. Okay, so to find the unit vector now, we're going to have to find the magnitude and then divide by the magnitude. Okay, so magnitude of OC, 4 squared plus 2 squared plus minus 4 squared is equal to 16 plus 4 plus 16, which is equal to root 36. So therefore, we can say that the unit vector, okay, what can we say for the unit vector here? Well, let's see. So, well, firstly we got 1 over root 36. It's 4. 2 times 18. Okay, and what we've got here is we can basically say, okay, we take out a 2 here, we can get 2 over root 36. Okay, and we'd get 2, 1, negative 2. Alright guys, now for question 4, what do we have here? So what we've got is, okay, the points A and B have position vectors 1, 2, negative 1, 3, 1, 3, 1, 1, and the line L has the following equation. Right, show that the line L does not intersect the line passing through A and B. Okay, so what do they want us to do here? Well, first off, what we have to do is you actually have to establish what the line AB represents. So AB can be defined as the following. OB minus OA, okay? And this therefore means, okay, that what we've got is OB, which is 311, minus OA, which is 1, 2 minus 1, okay, which gives me what? 2 minus 1, 2. So we've got AB, and so therefore what I can say is the equation of the line AB can be represented as the following: is R1 is equal to 1, 2, negative 1, okay, because that's what A represents, plus lambda, which is our multiplier here, 2, negative 1, 2. Okay, fine. So what does that represent? Well, it would be 1 plus 2 lambda, 2 minus lambda, negative 1 plus 2 lambda. Meanwhile, R equals what? R equals 2, 1, 1, okay, plus mu of 1, 1, 2, right? So now we have to show that L, okay, L, this thing, does not intersect this thing. So how do we show that? Well, naturally, if R1 is equal to R, then what we can say is 1 plus 2 lambda, okay, 2 minus lambda, and negative 1 plus 2 lambda. This thing over here. Surely, that's going to have to equal 2 plus mu, 1 plus mu, 1 plus 2 mu, right? So, that's if they're equal. And so what we can deduce from here is the following. We can say, okay, well, 1 plus 2 lambda is equal to 2 plus mu, which tells me that mu is equal to 2 lambda minus 1. Okay. And meanwhile, from the second equation, what we get is 2 minus lambda is equal to 1 plus mu. Which means what? Which means that lambda is going to equal negative mu plus 1. Okay. Okay, so it actually might be better for me just to say, well, from this, I can just say that mu is equal to 1 minus lambda. Okay, and now I can set them equal. That 1 equal 2. I can say then fine, 2 lambda minus 1 is equal to 1 minus lambda. 3 lambda minus 1 equals 1. 3 lambda equals 2. Lambda is equal to 2 over 3. What does it tell you? What that tells you is we now have to say, well, fine, we know lambda equals to 3. Okay, so therefore mu is just going to equal a third. Brilliant. So now what we do is we're going to sub them in. Okay, and see what value we get. Okay. So, what can we say here? Okay. So now we need to plug these in. So if R1 equals R, what we get is 1 plus 2 lambda. Okay, so 1 plus 2, 2 over 3. We get 2 minus 2 over 3, negative 1 plus 2 times 2 over 3. I'm going to put a question mark here. 2 plus a third 1 plus a third, 1 plus 2 thirds. Okay. Now if we work this out, just quickly. Okay, so 1 plus 2. 3. So 3. Right, so firstly, these both equal 7/3. Okay. And 2 minus 2/3. Well, what does that give you? 4/3. And what about 1 plus a third? Well, 1 plus a third also gives you 4/3. Okay. Now what about these ones? Well, -1 plus 2 times 2/3 is equal to what? Well, what that equals is a third, and that's it. Okay. But 1 plus 2/3 does not equal a third. Okay, so therefore what we can say, okay, is judging from that, okay, third coordinate of R1 does not equal the third coordinate of R2. Okay, so therefore line L does not intersect AB. Okay. And that's going to be your final answer, guys. Alright, guys, now question 5 is a bit of a chunkier question, alright? So what we've got here is a diagram that shows a three-dimensional shape. Okay. The base OABC, right, and the upper surface DEFG are identical horizontal rectangles. Alright, that's useful information. And the parallelograms OAED, okay, OAED and CBFG, right, lie in vertical planes. Got some midpoints, okay. Right, so a lot of information. So what we need to do firstly is just let's get through the questions that guide us, because that's a good way to go about it. So express each of the vectors PB and PQ in terms of I, J, and K. Right. Well, let's think about this. So for us to express this the way we want, we firstly have to find the base vectors. In this instance, that means OP and OB, okay? Right. So, let me see here. And also OQ, of course. So, OP. Well, let's think about it. OP. Sorry, this here. What does OP equal? Well, OP is simply equal to half OD, okay? Half of OD. Right, so I can say that's equal to half OD, which is the same as saying half of what? Well, OD is equal to 2, 0, 10. Okay, so it's 1, 0, 5. Simple enough. Now, meanwhile, OB OB equals what? Well, OB, if we find that this over here, how do we get there? We have to do OA plus AB, right? Now we know that OA is 6. Alright, so OB is equal to OA firstly, plus AB, right? And so we ask ourselves, well, how do we find AB? Well, you have to remember that AB is the same thing, has the same direction as OC, okay? Let me get that in red. Okay? Because remember what we were told. So, therefore, I can see that OB equals to OA plus OC, which equals simply, it's going to give me 600 plus 080, which gives me 680. Cool. So therefore, with that information, I can therefore say that PB is going to equal OB minus OP, okay, which is going to give me 680 minus OP, which is 105, which gives me 50. Yeah, sorry, 58 negative 5. Cool. So we got that. Now PQ. Well, what is OQ? Well, OQ, if we look up here, how do we get to OQ? The most obvious way would be to do OC plus CG, okay, plus GQ, right? So OC plus CG plus GQ, okay? So, what does that give us? That gives us OC plus CG plus GQ, right? Which corresponds to what? Well, what's OC first of all? Well, OC we know to be, in fact, even before I go there, we're not given these, okay? We have to deduct these further. So CG, what is CG? Well, CG is the same thing, has the same direction, shall I say, as OD. Okay, so OD is equal to what? 210. We can deal with that. Okay, so what we got is OC plus OD, and GQ is the same thing as let's see, so OA here, because we have OA, we can therefore find DE, which is the same thing as this, okay? And Q represents the midpoint, so all we have to do is split this in half. Okay, so what I can say is GQ is therefore going to equal half of OA, right? Cool. So what does that give me? Well, OC 080. Okay. And what's the next bit? OD, which is 2010. Plus half OA. What's OA? Well, OA is 600. Right, so what we get is the following. What we get is 2, 8, 10 plus a half 600, which equals 2, 8, 10 plus 3, 0, which gives 5, 8, 10. Okay, perfect. Now. PQ. What's PQ equal? Well, PQ, all right, is simply equal to OQ minus OP. Now we know what OQ is. This is OQ. And we know what OP is because we solved up there. So PQ is simply going to be 5, 8, 10 minus 105. Okay? Which gives you what? 6, 8, 5. Sorry, 4, 8, 5. My bad. Right? And that, guys, is going to be the final answer for number I. Now, what about II? Well, II says determine whether P is nearer to Q or to B. Well, how do we do that? Okay. So what I can say is, well, PQ. What does PQ equal? Well, the length of PQ, the magnitude of PQ, is equal to the square of 4 squared plus 8 squared plus 5 squared, which gives you what? Well, 16 plus 64 plus 25, which gives you the square root of 105. Okay. Meanwhile, the length of PB, remember, they're trying to work out, okay, from P, are we closer to Q or are we closer to B? That's what we're trying to work out here. So PB, okay, that's going to equal what? Length of PB is going to equal square of 5, okay, plus 8 squared plus negative 5 squared, okay, which is going to give me 25 plus 64 plus 25, which gives you what? The square root of 114, right? So let's think about it. Well, PQ, the magnitude of PQ is less than the magnitude of PB. This smaller than this. So therefore, what we can say is P is nearer to Q than to B. Okay? Perfect. So that's II. Now what about triple I? Well, for triple I, use a scalar product to find the angle BPQ. Okay? PQ. So, what do I do here? What I can say is, okay, what do they want? They want angle BPQ. Let's think about this. So PB dotted by PQ. Okay. It's going to equal the magnitude of PB. It's magnitude of PQ. Okay. Cos BPQ. Right. Cool. So, from here, what do we do? Well, we know what PB is. Okay. PB is equal to 5, 8, negative 5. And we know what PQ is. 4, 8, 5. Which then equals what? PB, which is, we go up, boom, 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 5, 8, negative 5. But remember, it's a it's magnitude here, so it's going to be root 114. Okay, root times what? Magnitude of PQ, root 105, right? Times cos BPQ. Right, so therefore what I can say, firstly, let's get this out. It's be 20 plus 64, 4 minus 25, so that's going to give me 59. Okay, is equal to these two times together, so 114 times 105. Let me see what's going to equal. Okay, so that's going to give me 11,170 gigs. Okay, so therefore I can say, in fact there's actually no point doing that, so therefore what I can say is cosine BPQ is going to equal 59 and 70, which gives me a value, being able to say that therefore BPQ is equal to 57.4 degrees. Okay, that is going to be your final answer, guys. Alright guys, now for question 6, we've got the following. It says, with respect to the origin O, points A and B have the position vectors given. So OA 6, 2, 0, OB 2, 2, 3. Okay, so the midpoint of OA is M. The point N for November in the meantime lying on AB between A and B such that AN is equal to 2NB. Okay, so find a vector equation for line through M and N. Right. So there's a good way to go about this. What we can say, alright, is, alright, A. Firstly, okay, so we know what, so OA, let's get this in the right form. So OA is equal to 6, 2, 0, and OB is equal to 2, 2, 3. Okay, cool. We know that. The midpoint of OA is M. Okay, so I can say that OM is equal to half of OA, which equals a half of 620, which is 310. Cool. Now, what I can say is, alright, well, given, okay, so given that over here AN is equal to 2NB, the question lies, right, how do we go from here, use this information to guide us, because at the end of the day what we're trying to find is MN. Okay, that's the goal, which means we're therefore going to need ON and OM. Okay, so we've got OM, we just need ON now. So, right, we can say that the ON minus OA, because that's effectively what this equals, right, is going to equal 2 OB minus ON. Okay, cool. So I can say that ON minus OA is equal to 2 OB minus 2 ON. Alright. So I can say that 3 ON minus OA is equal to 2 OB. Okay, so you plus this over. So therefore 3 ON is equal to 2 OB plus OA, which means that ON is going to equal what? ON is simply going to equal a third of 2 OB plus OA. So now we know the values for these, so we just plug in. So therefore, I can say that ON is equal to a third of 2 OB. Well, what's OB? So 446. Plus OA 620. Okay, which gives me what? Which equals a third of 1066, which gives me 10 over 3, 2, 2. Brilliant. So that's ON. And remember, we're trying to find MN over here. So, excuse me, MN naturally equals ON minus OM, which is therefore going to equal 10 over 3, 2, 2, minus OM, 310. Okay, now 10 over 3 minus 3, that's going to give me a third. Okay, so we got a third, 1, 2. And we found the direction vector then, guys. So this is our direction vector. Direction vector. Okay. And so if you need the direction vector, but OM, okay, is equal to what? OM is equal to 310. Okay, so therefore, what can I say? What I can say here, so the equation of MN is the following. It's R is equal to 310, right, plus lambda of a third, 1, 2. Brilliant. So that, guys, is going to be the answer to number A. Okay, it's going to be the answer to the first question. Now what about for number B? Find the position vector of P, so in other words OP, right? So we're told that the line MN intersects the line through OB at the point P. Okay, so first off, the line OB, okay, because that's effectively what this is about. O and B, the line through O and B. What is the line through O and B? So OB, we could say it's the origin. We give a value of mu for the multiplier, and it's just going to be OB, so 2, 2, 3. Okay. Cool. Fine. So, given what? So the line it intersects. Okay, so we have to do an intersection between MN and OB. Right, so if MN intersects OB, what do we say? We can say that 3 plus a third lambda, 1 plus lambda, 2 lambda, we could say that that equals 2 mu, 2 mu, and 3 mu, right? And this is actually an easier equation than we think, okay? Because what we can say then is, okay, 3 plus a third lambda is equal to 2 mu, which is our first equation. 1 plus lambda is equal to 2 mu, which is our second equation. Okay, and we can therefore solve this, so therefore 1 equals 2. I can remove the f actually. We can say that 3 plus lambda over 3 is equal to 1 plus lambda. So I can say 2 plus lambda over 3 is equal to lambda. So I can say that lambda minus lambda 3, okay, so 2 over 3, lambda is equal to 2. Right, so therefore what's lambda going to equal? Well, lambda is therefore going to equal 3, okay? Cool. Now, what I'm going to do is actually plug this into our third equation. Or actually, I can, let me see. Now I can plug into the second one. Okay, plugging. Doesn't really make a difference. 3, I can say fine. 1 plus 3, 2 mu. 2 mu is equal to 4. Lambda equals 2. Okay, cool. So we found both of these. So therefore, now that we have lambda and we have mu, we can therefore say, plug them in. Okay? We can plug them in if we find the point of intersection. Right? And the point of intersection is going to equal what? So this is the easier one to plug in. So therefore, okay, point of intersection OP is equal to 2, 2, 2, 2, 3, 2, 4, 4, 6. Okay, cool. So with that, okay, with that now, what we can say is therefore position vector of P is simply going to equal OP, which equals 4, 4, 6. Okay, and that's going to be the answer for B, guys. Meanwhile, for C, what do we get? So calculate the angle OPM, giving your answer in the previous case. I'm going to say here, we have to use a scalar products, most likely. So for angle OPM, right, let's see what we need to find here. So we're going to need OP, and we're going to need MP over here. So we know what OP is. OP is equal to 4, 4, 6. But what does MP equal? Okay, so we got OP, but you also need MP, okay? So what is MP going to equal? Well, that's going to equal OP minus OM, right? Which is going to be 446 minus OM. Which we calculated as, let's see where OM pops up again. Yes, the midpoint, yes, at 310. Okay, so 310, which equals what? 136. Great. So now we're just going to apply the scalar product. And say, okay, cool. So MP times dot product with OP is equal to the magnitude of MP times the magnitude of OP. I'm going to times that cos OPM. Okay. What's the dot product of MP and OP? Well, 4 plus 12 plus 36. Okay, so 4 plus 12 plus 36. Okay, that's going to give me 52. Okay, meanwhile we've got MP, which is 1 squared plus 3 squared plus 6 squared. OP 4 squared plus 4 squared plus 6 squared times cos OPM. So what I can say then is cos of OPM is going to equal 52 over 1 plus 9 plus 36. So 46 over 16 plus 16 plus 36. Which is going to give me 68. Okay. And then from here, if I plug that in, right, if I plug that in now, guys, OPM is therefore going to equal 21.6 degrees. Okay. And that is going to be the final answer for number C.